Hello everyone. The title of this video is Expanding Logarithmic Expressions. And in this video, I'm going to be doing some examples taken directly from a free online textbook at openstacks.org. I'm in their Algebra and Trigonometry text, section 6.5, called Logarithmic Properties. And I'm under the heading Expanding Logarithmic Expressions. Each example I do will be either one of the examples from the reading or one of the try it problems from the reading, or one of the exercises at the end of the section that's related to this particular objective. Okay, so before I get into the actual examples, I want to talk about here about, what does it mean when they ask us to expand a logarithmic expression? When they say expand a logarithmic expression, they want us to just basically, we'll be given a single logarithm, and we're going to use the product rule, quotient rule, and power rule that I've gone over in previous videos about this section. We just keep using those properties until you can't use them anymore. So I'm going to refresh your memory here about what were the product rule, quotient rule, and power rule for logarithms. So the product rule was this: if you have a logarithm, with any positive base of a product, right, m times n, you could express this in another way as a sum of two logarithms, or three logarithms, or four logarithms. It depends on how many factors are in the product. Here I only have two factors, m and n. So I can express this as the log base b of the first factor, m, plus the log base b of the second factor, n. That was the product rule. Log of a product is a sum of logarithms. All right, then we had the quotient rule, or fraction rule, if you want to call it that. So here's how that went. You have a logarithm, with any base, and then the input is a fraction, a quotient, right? Some sort of division with a numerator and a denominator. Numerator m, denominator n. And what we saw was the logarithm of a fraction, right? The logarithm of a quotient was a difference of logarithms, right? Subtraction. It's the logarithm of the numerator, right? So the log base b of m minus, and then the logarithm of the denominator, log base b of n. All right, then finally, the other property, the other rule we're going to make extensive use of in this video, the power rule for logarithms. So this went this way. If you have the logarithm, with any base of a power, so say m to the nth power. And the tricky part about this one was this input, right? The entire thing needs to be raised to a single power in order to be able to apply this power rule. If you saw this, the input was everything to a single power. You could pull that power out and write the exponent, right, n, pull that power out, times the logarithm of just the base, the logarithm base b of just m now. And these were equivalent. So, in this video, in the examples, we'll be given a single logarithm, and we're going to look inside the log and ask ourselves, do I have a product, or a fraction, a quotient, or a power? Is it all raised to one power? And if the answer to any of those questions is yes, then I will use the property, write the equivalent expression on the other side. And I keep doing this until I can't do it anymore. All right, so the first example I have is the following. We have the natural log. Remember, this is log base e. And then my input is a fraction, a quotient. All right, there is a single numerator and denominator. So I see a quotient, I see a fraction inside the log. So I'm going to apply the quotient rule first. So we have the natural log of the numerator, right, x to the fourth times y, minus the natural log of the denominator, which is just 7. Okay, so step 1's done, and then I keep looking inside the logarithms at the inputs and ask, do I have a product? Do I have a fraction, a quotient, or is it all raised to a single power? All right, so looking inside this first logarithm, I see a product. Yes, there is a power, but as I mentioned, the entire input here is not raised to the fourth power, just this x. So I can't apply the power rule. Right? You can't just pull powers out whenever you want. But I do see a product here. Right? It's a product of x to the fourth and y. And then for the natural log of 7, I'm done. Because 7 is not a product, it's not a fraction, and it's not all raised to some power. Right? So then I'm applying the product rule to this first logarithm. So this is equal to the natural log of the first factor, x to the fourth, plus the natural log of y, the second factor. All right, and then we still have this minus the natural log of 7 from earlier. All right, I'm almost finished. So now again, I go back and look inside the logarithms and ask, do I have a product or a quotient or a power? And then, inside this first log, finally, I can apply the power rule. Everything in here is raised to the fourth power, right, to a single power. So I can apply the power rule to that first logarithm. And then the natural log of y is done. Y is not a product, it's not a fraction, and it's not raised to some power. So then I finally apply the power rule to this first term, pull the 4 out front. So then we have 4 times the natural log of x plus the natural log of y minus the natural log of 7. And there we go. And now looking inside each of the logs, there are no more products, there are no more fractions, and there are no more powers. So this is as far as it goes when you're asked to expand completely. And that's it. Wonderful. And this is all we're doing for all these examples. All right, so I got something similar here in example 2. As to expand this logarithm. So I look inside the logarithm, and the first thing I notice is that it is a fraction. There's a numerator and a denominator. So I'm going to apply that quotient rule. So this will be equal to the log. Now remember, this is log base 10. Right? There is no base, so it's common log base 10. The log of the numerator, x squared times y cubed, minus the log of the denominator, right? The log of z to the fourth. And then inside this first log, there's a product, right? Again, you can't just pull the powers out, right? Not everything in here is raised to the second. Not everything in here is raised to the third. There's not just a single power that the whole thing is raised to. So I can't use the power rule here, but I can use the product rule. So this log of x squared times y cubed, I can rewrite as the log of x squared plus the log of y cubed. All right, and then minus, and then this second log from the previous line, that z to the fourth, that's a power. All right, everything in here is raised to the fourth power, so I could pull that 4 out front. Make that last log minus 4 times the log of z, applying the power rule. And then I just have two more cases, two more times I can apply the power rule here. You see this log of x squared, that's a power. I can pull the 2 out front. And the log of y cubed, that's a power. I could pull that 3 out front. And it's all raised to a single power, right? That's the only time you can apply the power rule. So 2 comes out front there, so it's 2 times the log of x plus, and then 3 comes out front here, 3 times the log of y, and then I'm already done with the last one, which is the minus 4 times the log of z. And these should be equivalent, as long as whatever you plug in for x, y, and z are positive numbers, because remember, you can't have negative numbers inside logarithms. And you can test that out with a calculator if you wish, and see if these are actually equivalent for your choices of x, y, and z. Wonderful. All right. Now the next couple of examples have some roots in them, square roots, cube roots. So example 3, we have the log of the square root of x, and again we're asked to expand, apply one of those properties until you can't use them anymore. So hopefully you recall that the square root of x is a power of x. It's actually the same thing as x to the 1/2 power. Remember, fraction powers are equivalent to roots, radicals. And now I have a power, right? Everything in here is raised to the 1/2 power, so I can pull that half out applying the power rule. So we have 1/2 times the log of x. And I'm done. And once again, you can double check, go to a calculator or something. I'm not going to do that here though, I'll leave it to you. But these should be the same expression, the same value, no matter what you plug in for x, as long as it's a positive number, of course. Okay. Something very similar here. I have the natural log of the cube root of x squared. And off to the side here, remember the cube root of x squared is the same thing as, x squared to the 1/3 power, which if you apply that power to a power property for exponents, this is the same thing as x to the 2/3 power. So that's how I'm going to rewrite it, right? This is the natural log, and then this cube root of x squared is just x to the 2/3 power. And then once again I can apply the power rule for logarithms, right? The expression inside the log is all raised to a single power. So you pull that power out front, make it 2/3 times, and then just the natural log of x. And there we go, and then I'm done. There's no other properties to be used. Wonderful. Alright, and then just more of the same. So example 5. So again, I'm seeing a fraction first. There's one numerator, one denominator. So first I'll do the log of the quotient rule. Right, the log base 6 of the numerator, which has 3 factors, 64 times x cubed times the quantity 4x plus 1, minus, and then the log base 6 of the denominator, which is that 2x minus 1. Alright, so that's applying the quotient rule. And then I'm seeing a product inside this first logarithm. Now it's got 3 factors, 64 and x cubed and 4x plus 1. So I'm going to apply the product rule and rewrite this as a sum of 3 logarithms. That's the logarithm base 6 of 64 plus the logarithm base 6 of x cubed, right, the second factor, plus the logarithm base 6 of 4x plus 1, right, that third factor. And then don't forget we still have the minus log base 6 of 2x minus 1. Okay. Now, 64, usually when there's just a number inside a logarithm, they'll just, you can leave it and that's totally fine. But 64 is actually a nice power of 2. It's 2 to the 6th power. That's 64. So if I think of this as a power, I can pull the 6 out, right? Pull this power of 6 out front and make this 6 times the log base 6 of 2, right? If you want. You could also leave it as 64, but if you want, if I just wanted to have an excuse to use the power rule there. Then the same thing goes for this one here, this second log. The x cubed is a power. I can pull that power out, pull the 3 out. 3 times the log base 6 of x. Then these last two are not products, not fractions, and not all raised to some power. So these stay the way they are. Plus the log base 6 of 4x plus 1 minus the log base 6 of 2x minus 1. Right? If you have a sum or a difference inside a log, there's really nothing you're going to do with that. There is no sum rule or difference rule. Only products and quotients and powers can you rewrite the logarithm. And there we go. That's about as expanded as that's going to get. And once again, if you wish, you can go to the Desmos calculator as I've done in previous videos and see that these expressions, the beginning and the end, are equal for all the common values of the x values that they have common to their domains. Okay. Then again, more of the same. Doing the same thing for all of these, just expanding using those 3 properties until I can't use them anymore. So here I have another fraction inside the logarithm. So I'm going to use that quotient rule first, with the natural log of, and the numerator, you have this expression under a square root. Now remember, that's the half power, so I'm going to write it this way. We have the quantity x minus 1 times the quantity 2x plus 1 squared to the 1/2 power. Right? That's the whole thing, with the square root to the 1/2 power. So there's the log of the numerator minus, and then the natural log of the denominator. Now here's something I'm going to do as well with this denominator. X squared minus 9 is factorable. Right? I can write x squared minus 9 as a product and then apply the product rule. Remember, this is a difference of squares. This would factor to x minus 3 times x plus 3. So that is how I'm going to write the denominator here. X minus 3 times x plus 3, right, instead of x squared minus 9. Okay, then in this first logarithm, everything in here is raised to the 1/2 power, so I can apply the power rule. Pull that half out. So I have half times the natural log of x minus 1 times 2x plus 1 squared, right, with the half pulled out. And here I have a product in this second logarithm. Now I've done this in previous videos as well. You're not just subtracting one term of the log, you're subtracting the entirety of what the log is equal to. So I'm going to put parentheses here after the minus sign, and then we're going to write an equivalent statement for the logarithm using the product rule. So we're subtracting all of this, the natural log of x minus 3 plus the natural log of x plus 3, right? Applying the product rule to that logarithm. And we'll distribute the negative sign here in a second, right? So I'll distribute the minus sign, make both these, negative log, negative log. All right, and then same thing now in this first logarithm, I have a product. But it's, it doesn't have the number 1 in front of it, it has a half. You're not just multiplying the first term by a half, you're multiplying the whole thing by a half. So kind of like with the minus sign earlier, I put the half times, and then in parentheses, what this log is equal to, using the product rule. The natural log of x minus 1 plus the natural log of the 2x plus 1 to the second power. And close the parentheses, right? So after this line, I'm going to distribute this half. I'm going to distribute this half. Now, after distributing the negative from the previous line, we have minus the natural log of x minus 3, and then minus the natural log of x plus 3. And then finally, I'm going to distribute this half, get rid of these parentheses here, and pull the power out. Right, you have 2x plus 1 to the second power, that's a power. Pull the power out using the power rule. But if I pull the 2 out, I have 2 times this log, but then I get multiplied by a half, that becomes 1. So we have half times the natural log of x minus 1 plus, and then 2 times a half, which is just 1, times the natural log of 2x plus 1. Alright, the power got pulled out. And then all this rest of the stuff stays the same, minus the natural log of x minus 3 minus the natural log of x plus 3. And this is, I would say, as expanded as that expression can get. Okay. Now you got to be careful when there's numbers other than 1 in front of a logarithm, because then when you rewrite that logarithm, you're going to have to distribute that number, like the negative 1 here and the positive half here. Okay, wonderful. All right, and I have just one final page with a couple more examples of this. Again, I'm doing the same thing every time. Just asked to expand the logarithm, keep using those properties till you can't use them anymore. All right, so up top here, I see a fraction first, numerator, denominator. So I'm going to use that quotient rule. Natural log of the numerator, right, a to the negative second, minus, and then the natural log of the denominator, which is b to the negative fourth times c to the fifth. And then in the first term, the first logarithm, I can use the power rule, pull that negative 2 out. Negative 2 times the natural log of just a. And then just as in the previous example, the number in front of the second log isn't 1, it's negative 1. So I got to make sure I do this, minus the quantity, minus, and then put parentheses, and then we'll distribute the negative 1. Here I have the natural log of a product. Right, the natural log of b to the negative fourth plus the natural log of c to the fifth, and then we'll distribute this negative. So on the final line, I'm applying the power rule to these, pulling the negative 4 out, pulling the 5 out, and then of course distributing the negative. So we have negative 2 times the natural log of a, and then if I pull the negative 4 out using the power rule and then multiply by negative 1, that becomes positive 4 times the natural log of b, and then pulling the 5 out, but then multiplying by negative 1 makes that last log negative 5 times the natural log of c. And that's as expanded as that will get. Right, you can't use the product, quotient, or power rules anymore. Wonderful. All right, and just one final one. All right, now in this last one, yes, there's a fraction, but I do see a product first, right? It's not just one numerator and one denominator like those other ones, right? That's the only time you can apply the quotient rule, if it's all one numerator over one denominator. But I do see a product here, so I'll apply the product rule. this will be equal to the natural log of the first factor, which is y, plus, and then as I've been doing with the other roots, right, square root is to the half power. This is the natural log of, and then you have inside that log y divided by 1 minus y to the half power. That's the square root of y divided by 1 minus y. And then I can apply the power rule to this second logarithm, pull the half out. So you have the natural log of y plus half times the natural log of now a fraction, just y divided by 1 minus y. And then just as I've been doing the previous examples, the number in front of this log is not 1, it's a half. So I'm going to be, when I rewrite this logarithm using the quotient rule, I'm going to have to then distribute that half. So we have the natural log of y plus 1/2 times the quantity, and then this natural log of a fraction, I'm using the quotient rule, right? Rewriting that as the natural log of y minus the natural log of 1 minus y. And then to get rid of those last set of parentheses, those last grouping symbols, I'm distributing the half. And then we finally end up with this, that natural log of y plus half the natural log of y. And I guess I could write one more line after this because these have the same term. These are both like terms. They both have natural log of y, so I can put them together. And then minus half of the natural log of 1 minus y. And yeah, I think I'll do that. You see this has natural log of y, this has natural log of y, so you can combine them. 1 plus a half is 3 halves. 1 1/2, 1.5. So I have 3 halves times the natural log of y, and then minus the 1/2 times the natural log of 1 minus y. And that is as expanded and simplified as that expression can get. And once again, if you want to check it out, punch these expressions into your calculators, Desmos, whatever. Plug in different values of y. Once again, as long as you have positive numbers inside of your logarithms, you're good. And no matter what you plug in for y, as long as they're allowed to be plugged in, these will be equivalent expressions, or at least they should be. And that's it. That's all the examples I have. Like I said, anytime you're asked to expand a logarithm, you just keep using those properties, the product rule, quotient rule, and power rule, until you can't use them anymore. And I'm hoping that watching me go through these 8 examples here helps you in some way, when you're asked to expand a logarithm on your own. And thank you very much for watching.